Welcome back to another episode. Today I'm super excited because we have with us Adhokshraj Mishra sir, a staff detection engineer at SentinelOne, and someone who has deeply involved research in malware, Linux, defensive aviation, and applied cryptography. He's worked with a lot of top companies and he's very known well for his research. So, in this episode, we'll try to dive into the future of Linux, malware, defensive evasion, cryptography, and many types of attacks, and some fun stories from his journey as well. So, sir, welcome to this podcast.
Thank
Let's
you.
start with a quick introduction about you and answering the question. Is it a myth or a fact beginners in cybersecurity feel the term cybersecurity is just hacking and firewalls. So from your perspective, can you explain it?
Okay, so yes, it is true that it is a general misconception because hacking looks cool, at least on screen, that you do
Hmm.
something and then boom, I have access, right?
Yeah.
But then there are many other specialties in security which are not that glorious looking on the screen. For example,
Hmm.
there is this whole vertical for risk and compliance, right?
Yes.
That at least partially overlaps with security, but is not looking glorious on the screen, right? There is malware analysis, there is reverse engineering, again, doesn't really look glorious. There is security engineering, where you basically design specific architectures and do the engineering in a way that your architecture itself is secure by design.
Yes.
Okay, architecture is one part, implementation in some particular language and set of frameworks is entirely different part, and you need to keep both secure. Okay, so that also comes inside security. Okay, and then there is research part where you basically do the research on offensive and defensive both. And I will give you examples for both. So for offensive, you may think like trying to figure out how to break existing security solutions, products, etc., for embedded, for IoT, for automobiles, for aviation, for telecom, for medical devices, etc. Or you can get into research on defensive side, basically securing all these things. Or you can research in exploit writing stuff for exploitation, or you can go in research in opposite of exploit writing, where you do some stuff in code generation, where you basically neutralize at least some class of techniques which enable exploit writing. For example, there is something called ROP chaining, okay, return-oriented programming, and that used to be very common technique for writing exploits, and we were getting started. Then compilers got updated, and it turned out that there are ways to generate code where you don't really get that many ROP gadgets in the binary. So if you don't get ROP gadgets, you can't really chain them, and the whole technique basically uh, breaks apart, right? Similarly, there is something called control flow integrity. There is something called forward CFI, backward CFI. So all those things eventually fall somewhere in security. They may not be entirely within security. A lot of these things also overlap with general research. They also overlap with computer science. They also overlap with engineering, but they are still in some sense part of security, right? So all this comes under security, but the problem is that either these things don't look glorious on the screen, right? Or the entry barrier is very high.
Hmm.
Okay, for example, if we talk about that CFI thing, again, if you want to get into control flow integrity, how to ensure the integrity, how to break it apart, etc., that is not something that you can pick up in short span of time, right? You need to go through a lot of subjects, study a lot of topics, get your hands dirty on a lot of things before you start dabbling into that side of security. Okay, and that is basically a rather painful process.
Hmm.
In hacking, you have a bunch of ready-made tools.
Yeah.
Okay, so you take any random YouTube video, And they will be like, oh my God, guys, I come to office, I have my coffee, and here, I run this command, this tool, and boom, I hacked.
Yes.
So that looks like, hey, this tool is available for free, or maybe it is not very expensive. I can download it, purchase some course, and at least pretend that I am a hacker.
Hmm.
Okay, then there is opposite side which is busy patching the stupid stuff that these hackers are doing, and that
Hmm.
again also falls under security. But again, that is not flashy. That doesn't look glorious,
Hmm.
right? And that is why people don't really realize that these are also aspects of security, and these are also basically legit career opportunities. You can build your entire career in those domains, and there are crap ton of people who have done so, right? But the primary reason that doesn't look flashy on screen, you can't really sell that via YouTube Shorts.
But if someone decided, even if it doesn't look that great, even if it's like what it is, I'm liking what I'm seeing on the screen, and I want to still pursue this. So how should they start their career, or from like BTech and all?
Okay, so in that case, they will have to basically figure out some pathway for their chosen specialty. Okay.
Okay.
Again, I don't really have idea about all particular specialties in security, but for the line of work I do, detection engineering, I can talk about that. Okay. So if you are someone who wants to get into detection engineering, there are a bunch of things that you need to sort out first before you step your foot in your first job. One, you need to be really good with programming. Okay, whether you like it or not, you may not be doing engineering, you may not be contributing code in the product itself, in the engineering side of things, but you will still need code and a lot of code to automate parts of your own job, to automate bunch of analysis, etc., etc. Without writing at least some amount of code, you won't really be able to pull that off. That is one part. Second is you need to pick at least one platform. Okay, and you need to study the hell out of it. Maybe you want to get into Windows, that is fine. Maybe you want to get into Linux, that is fine. Maybe you want to get into Mac OS, Android, iOS, whatever. Okay. You need to pick at least one platform and take a really, really deep dive inside that.
Okay.
Okay. From user mode to kernel mode, to how things are working, how processes are created, destroyed, managed, memory allocation, memory management. There are various stacks in kernel, how they are functioning, how they basically talk to each other, etc., etc. A lot of things are there. So you need to study that part as well. Okay,
Okay.
and then you need to understand the offense and defense, both sides.
Mm.
Okay, whether you want to go into offensive side, whether you want to go into defensive side, you can't really chicken out saying that, hey, I am a hacker, so I don't need to study the defensive side.
Hmm.
You can't really chicken out saying that, hey, I am the defensive guy, I'm easily SOC analyst, I don't need to dig into offensive side. That is not how it works. You need to be familiar with both sides. Obviously, you will be biased towards some particular side. That is okay, but that doesn't mean that you skip the other side of one. Okay. So for detection engineering, obviously, you need at least some hands-on experience, some familiarity with how attacks happen. And then you should also know how you can replicate those attacks and how to analyze that. Okay, which means that you also need to know how to reverse engineer it, how to uh, basically debug things. Okay, then you combine this with operating system internal knowledge. Okay,
Hmm.
and then you basically try to think: is there some way where I can collect some information from some corners of the system?
Hmm.
And is there some way that I can correlate them in a manner where I can say that if these and these and these are happening in this particular manner and these conditions are satisfied, that means this particular attack technique has happened.
Okay.
Okay, so you do that part. right? And then that thing gets codified in some way. Maybe it will become codified as detection as code. Maybe it will be some chain of conditions. Maybe it will result in some enhancement in your security product, whatever. But you need to figure out that part. And for that, you can start like this. Now, for getting started in your career, once you have sorted out your basics, uh, you can either start from SOC related roles, okay,
Okay.
SOC analyst type of things. Why SOC analyst? Because you get to see how detections happen. Okay, you get to see how telemetries are coming, what sort of data you are getting in the telemetry, pros and cons of various different approaches. And when you are working as a SOC analyst, don't limit yourself into those SOPs. Obviously, as far as your office is concerned, you need to stick to SOP, but that doesn't mean that you stop learning outside that SOP.
True.
Okay, your SOP says that, hey, we have established some automation, some internal pipeline for this. For sure, you need to follow that. But
Hmm.
you also need to learn how that pipeline is functioning. How will you do that if you don't have the pipeline and you are in a position where you have to invent that pipeline to begin with?
Okay.
Okay, you need to get into those parts, study the heck out of that. You need to learn how to write detections on whatever platform you are using. You need to learn how those tools are capturing the telemetry. What are the limitations? What are the flaws? What are the cons? Right? Then you
Yeah.
try to bypass your own detections,
Yeah.
and then you try to write a detection for your own bypassing. Okay, you do this for a couple of years, then you can transition into something called you can either pick malware analysis in the side or do incident response, root cause analysis. Okay, that overlaps pretty nicely with SOC roles because you have already spent at least 2 3 years writing detections and figuring out where things are going wrong. So by doing the malware analysis or incident response, you get to see the artifacts which are left on the system as a result of that particular incident. Or
Hmm.
in malware analysis, you get to see how things are laid out inside a malware, how various techniques are being implemented. Okay,
Hmm.
and that gives you an insight how you can detect that. Okay,
Okay.
because you also need to prevent false positives. So you will
Yes.
spend doing that, and then you slowly move into more on writing detection side of things, and then from there you can pivot into some role which is more and more on research side, and
Okay.
eventually you basically switch in detection engineering in some sort of uh, uh, a security product company, because those are the companies which hire, which basically have teams for detection engineering. So this is a largely well established path, and we
Okay.
see a lot of people who are coming from similar routes. They start either VAPT or SOC, from SOC to incident response or malware analysis, and then eventually they start writing more and more complicated detections and correlations, and then they eventually move into that. Okay, we are at a stage where we understand at least basic to intermediate stuff, and now we can probably start researching on that. And then in these research roles, they barely need like 5 6 months or so to get familiar with how this research part happens. Because when
Okay.
we say that it is research, we are effectively trying to chart some unknown territory,
Yeah.
right? So they take like 6 months or so, and that is enough to for them to uh, be productive in research side of things.
Hmm.
So this is a pretty well established path at this point, I will say. So if someone is willing to put that much effort and willing to learn that much stuff, the path is still very much open. It's just that people don't know too much about this, because again, this is not something that will look glorious or rather glamorous on the screen. Like, if you
Yeah.
ask me that how does my average day looks like, it looks very boring.
Hmm.
Okay, you will see staring me at crap ton of data and doing some stuff to figure out how I can basically fine tune the important things from the data. How do I figure out what to drop, what not to drop, what to correlate with that, right? There's a lot of time which is spent inside data, then time spent inside programming or automating some stuff, writing some detections, then testing those detections, then there are other things as well. All in all, it looks very boring on the screen, right? So this is not something that I can sell on YouTube by showing how my average day looks like, because that will look absolutely boring, and people don't want to do boring stuff.
Yeah. But you said, like, you gave an example of SOC, how you start from SOC and then go into product based company. But what if, like, wouldn't a VAPT person have more advantage over the SOC guy in going into, going into malware and all? Because they are oriented like towards finding that type of bug. They need
Again,
to know this.
yes, from VAPT, you all, as well, you can get into these roles, but again, you will at least need to know how you can detect those things.
Huh.
Okay. Even if someone is coming from SOC, we still ask attack related questions.
Yeah.
Okay. If someone is coming from VAPT background or a team background, we still ask about how do you detect this? What
Hmm.
will you capture? How will you correlate? It is fine if they have not written a single actual detection for some particular product. Okay. But it is more important that they at least understand how the detections can be made. The actual implementation will vary from one company to another, one product to another,
Hmm.
but they need to be good enough to figure out at least in principle detections, that if we intercept this activity, if we get this information from this corner of the system, and if we correlate them in this particular way and put these set of conditions, this will result in a very reliable detection for this particular attack or this particular malware technique.
Hmm.
Okay, so it is absolutely fine. It is just that in India, people from VAPT to progress to red team and then they become managers.
Yeah. So you have to be a purple teamer in shorts if you want to go
Yes, yes,
into.
yes, 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 yes. Yeah, you need to be kind of a purple teamer where you understand attack and defense both. You can be biased toward either attack or defense, it is fine, but you need to understand both.
Okay. You said, you mentioned a line you were telling that your day is very boring and that you look at data, then you do development, and then you do testing. So you're
Yes.
only the person who's doing the same thing, because in like develop SDLC cycle and all we see, the development and testing team is different. So for your expertise, it's the same. It's okay with the same person.
Okay, so we have a team of n number of people. Okay.
Mm.
And again, it is fine if one person does the analysis, second person does the actual detection, writing in some particular way under some constraint. It is fine, and it is also fine if someone is doing whole thing end to end. It basically comes to personal preferences. Okay, so when I say that I do like this, I don't mean that I don't take help. I absolutely do. Sometimes I will ask some other person to take a look at whatever I have cooked. Sometimes I will be taking a second look. Sometimes we will be sitting same meeting trying to figure out how to solve some particular problem in whatever we are doing, right? Sometimes we will eventually realize that, hey, all of us are just trying to solve specific cases of some more general problem statement. So why not take a step back, discuss this out, and see if we should be taking a little bit more general approach and putting some specific, much easier conditions on it or not. So again, that comes to basically personal preferences. Right? There is no uh, specific rule that you have to do everything alone or you have to split it in this particular way. It is kind of open. Okay, we do it as we see fit.
Hmm.
Okay, people outside my team probably don't even care how that detection was written. All they care about that, yes, we have a reliable detection. Yes, there is some sort of improvement in the product.
Hmm.
Right? Customer doesn't care how the detection was written, whether the data was analyzed by 1%, 10 people, or whole team was working on one particular detection. Customer doesn't care. Right? So we do that as we see fit. That changes from case to case.
You know why I asked this question? Because in GRC I learned that testing data, development data is different. And supposing like if like a junior person, junior level person is like making the development code itself or some document and all, and they are only doing documenting, developing, they are only testing and they are only passing. हाँ सब ठीक है, pass कर दो, the issue in passing the software. And
No,
then
no.
we
Okay,
do.
okay. In practice, in industry, if you see those side of things, the person who says that okay, this is good enough and we can proceed with it is not the person who wrote that thing. Okay.
Mm-hmm.
So if I am the one who is writing some detection, that
Mm-hmm.
has to be approved by someone who is not me.
Okay.
Okay. Similarly, if
Obviously.
that guy is writing the detection, sometimes I will be the person who say that okay, yes, this looks good. We can move ahead with this. So
Mm.
maker and checker are two different people.
Yeah.
And the basic idea is that many times what will happen that we are so much entrenched in our own specific way of thinking that we may end up missing something obvious. We may end up missing some corner case. We may end up fat fingering some parameters, right? So a second set of eyes are always helpful,
Mm.
right? Second set of eyes, and they will be probably able to see that much easily that okay, I missed something, or I basically fat fingered some particular parameter. So that is why maker and checker are never the same.
Mm.
And even then, there are some bunch of automated things which will check for certain specific things that okay, those conditions should be satisfied. So even if the checker misses something obvious, those are still caught in some sort of automated script.
Mm-hmm. Okay. Let's come back to Linux. Linux, I've read somewhere, it's often seen like very secure. Even you told me it's secure by default. But we know that a Linux system is very prone to attacks. So, like, what are some challenges in detecting malware on Linux compared to Windows? Because Windows
Okay,
keeps
so
giving update.
okay, saying that Linux is secure by default is not really correct.
Okay.
Okay, it is not true that Windows is insecure by default. Two platforms they took different priorities, different designs, etc., etc. That is fine. But the thing is that average Linux user is more knowledgeable about computers than average Windows user.
Okay.
And these average knowledgeable users of Linux tend to not do utter stupid shit.
Yeah.
Okay, you won't see a Linux guy downloading free movie downloader.exe.
Yeah.
On Windows, that used to be routine. Not sure how things are these days. Okay. Now, when it comes to the detection part, it is not that detection on Linux is difficult. Detection part is actually pretty much
Simple.
solvable problem, right? It is difficult to basically lock down, and to pretty good extent, they are designed to be managed.
Mm.
Okay, which means that if you take a Windows machine, which is being managed by some sort of centralized management system,
Okay.
you can lock it down very tightly. So
Mm.
tightly that user will not even be able to change wallpaper. Okay, you can control every single aspect of Windows.
Windows.
Pretty much same thing is true about macOS as well. At least most of the stuff can be centrally managed and centrally locked out as well.
Mm.
Okay. On Linux, it is different. Linux was not designed to be centrally locked down. Okay.
Okay.
Linux has opposite philosophy saying that user has ultimate control.
Mm.
Okay. Which means that there will be a lot of cases where you don't really have any effective uh, prevention strategy apart from basically killing the process.
Yeah.
Okay, on Windows, on Mac OS, you can block certain specific activities from happening, and process is not randomly killed as long as it is handling those errors gracefully. Okay,
Mm.
that process, if that process is programmed properly to handle all the possible error cases gracefully, it will not get nuked out of existence. On Linux, way too many times that thing is not really possible. So we have to resort to basically killing the process. And that makes it kind of difficult. Okay,
Okay.
because by killing the process, we basically take the nuclear approach that, okay, destroy everything.
Yeah.
So that is the problem with Linux. It doesn't want to get managed, right? If you want to collect telemetry, you are more than welcome to do so. But those hooks are going to be read only. You get a copy of data to read. You can't
Hmm.
modify that for most part. And it
Okay.
is something that Linux actively resists. Okay, so for a lot of things, you need to get into specific corners of the kernel, and kernel is basically a moving goalpost, and it is moving goalpost because political reasons. The reasons are not entirely technical. It is part technical, part political. It is not true that there are no technical regions and they are changing it just for fun. That is also not true. There are technical regions, but also there are political reasons to keep it so that you can't really rely on some particular kernel corner to be stable enough across kernel versions, and that makes it rather challenging in
Hmm.
comparison to Windows and Linux, Windows and Mac OS.
What, since we are talking about evasion only, have you seen any like real world evasion technique that make EDR struggle on Linux systems?
Okay, I have seen many, but most of them boil down to basically file path manipulation. And the problem with file path, on one hand, on surface, it will look like that. Okay, a lot of things in Linux are basically like files. So if we sort out the file monitoring, we can basically identify all of them.
Yeah.
And then Linux comes in the picture saying that, hey, this operating system was made by hackers for hackers. Okay. So we don't give two shits to what you think or you don't think. And the result is that if you are on Windows or on
Hmm.
Mac OS, there are not really many ways to make a file path appear as something else. Okay. On
Okay.
Mac OS, you have symlinks. At max, you can do uh, a repeated mount or something, but it is where the possibilities basically end, right? The same story for Windows as well. Then comes Linux. You
Hmm.
have Symlink. You have Symlinks from procfs. You have mount bind. You have duplicate mount. You have file system namespaces. You have root jails. You have a bunch of other types of jails which also do things like root, but in slightly different ways. The end result is that same file path can appear like something wildly different. And
Okay.
unless you figure out how do you uh, basically manage these things and figure out that, okay, this file path is pointing to the file which is actually that original file path in which we were interested in, which means that these are the exactly same files. And that means that if something happens via that particular path, we need to trigger alert here. Either way, again, if you take this problem to someone who knows Linux, he will say that, okay, this is largely a solved problem. You just need to call stat on both paths and you need to compare the tuple of inode and device identifiers. And that tuple, if the tuple is matching, that means both are pointing to the exact same file on the storage medium. But the opposite side is that if you try to pull that off, you will end up with bunch of weird corner cases. For example, in some particular cases, you may end up tracking so many cases that you will be basically running out of memory. You are running an EDR. You can't really eat too much resource on the endpoint, otherwise people will not really use your product,
Hmm.
right? And then there are cases where you want to, where you should be basically tracking inode. And there are cases where you should be actually tracking path because again that depends upon how other parts of the system which are using that particular path are going to use it. And if there is some service which will open the file path every time it needs to read, right? It will depend upon the file path, and it won't really care about the specific inode number it is pointing to. But if the process is designed in a way that it will open the file in the starting and then it will close it only when it is exiting, then it is going to care about inode. You can basically make the path look like something else, but it will still hold on to the original inode. And
Mm.
unless you know all this stuff on the fly somehow, by some magic, you are not really going to uh, handle this accurately in a way that it is not that it shouldn't really break anything for anything else, and that becomes ridiculously hard problem, right? And that is why these things result in really tasty, crispy, crunchy evasions on Linux.
Mm. Okay. Is there any memorable malware sample or anything that you analyzed that surprised you in terms of like defense, evasion, or creativity?
It has been an eternity since I analyzed any malware. I have written POCs for various techniques from various descriptions. But again,
Okay.
the thing is that you won't really see a lot of creativity in run-of-the-mill malware.
Okay.
Okay, because if you have something exotic, why will you burn it in the wild? You will keep it safe and secure, and you will use it only in targeted campaigns
Hmm.
where you can basically minimize the exposure to other people.
Hmm.
Because as soon as your sample is captured, the technique is basically gone. It will be written by on some blog. That blog will be read by people like me. Our sample will end up with threat intelligence teams, right? And they will pass it on to malware analysis team, and they will drag people like me in the meeting saying, "Hey, we have something here. Can you do something about it?" And at that stage, you can be very much assured that there are multiple levels of detections are going to come out. The exotic techniques and run-of-the-mill samples don't really belong in same sentence.
Okay. But you mentioned so many groups, threat intelligence, malware analysis, then it comes to you. These, what are like, uh, what do these groups do? What is their main responsibility? That still the malware is coming to you at the end to get
Okay,
analyzed.
so different groups specialize in different things. Okay, so
Huh.
threat intelligence is group is something which will be doing something like collecting information, right? Trying to figure out if something bad is happening somewhere. And these are the people who will have presence in a lot of weird corners of internet in one way or another.
Okay.
Okay. A lot of forums, a lot of groups, a lot of Telegram groups, shady groups as well,
Huh.
even on dark web, right? And in many cases, these very people will be pretending to be some sort of potential buyer for some particular offensive toolkit.
Okay.
Okay. Or they will be part of some forum where some discussion will be happening, and then they will be like, okay, we have seen this discussion happening,
Hmm.
which means that something like this is going to happen. These people are talking about some new particular 0 day. I don't really have the sample right now,
Hmm.
but this is the discussion they are having, and we need to do something about it. Okay. Many times they will end up finding the sample before the world has caught up with that, and then they pass it on to malware analysis saying that, hey, we got this fresh off the oven sample.
Hmm.
Okay, take a look and figure out what we can do about it. And then malware analysis group will be like, within hours, they will have dissected it completely.
Acha.
Okay. And then they will immediately figure out, okay, we already cover these sort of techniques. So there must be some detection. Just
Hmm.
for a sanity check, there will be a trial run where they will run that particular sample in a sandbox and see if we are catching it appropriately or not, right? And
Hmm.
further, they will prepare a quick report saying that, okay, these are the techniques, these are the particular ways of implementation, right? Then there will be two more teams. Again, this will vary from company to company. There will be cases where both are handled by same team, different team again. So at least there will be, when I say team, just take it as some group of people. Okay. Then
Okay.
for detection, or rather more accurate detection, there is detection like we identify some of the steps, but we don't
Mm.
pin it down in a more specific manner, saying that okay, this is this particular malware sample. So there will be at least some people or some team who knows how to write static detections based on file contents or based on how the process memory looks. Okay, memory contents, and they will figure out. They will basically publish a static detection where if you end up scanning your storage, right, it will flag the binary based on its signature or a process based on signature in whatever data it happens to have inside memory. Okay. Then there will be another set of people who specialize in behavior-based detection, and they will be focusing more on what APIs are being called, what system calls are being called, in which particular order they are being called, what parameters are being supplied, and in that whole group of API and system calls and their parameters and their specific values, is there something which can tell us very reliably that this particular thing is happening? And if we find something like that, we write a detection based on that, right? And we push it out. And then we revisit that, okay? And we revisit it to basically ensure that, okay, this is one particular implementation or this particular technique. And if someone is going to this particular length to implement this particular technique in this particular way, what else they can do? What are other possible similar implementations or similar type of techniques which will break our immediate detection, right? And
Mm.
then we cover those cases as well. And eventually the detection becomes like, even if you use some alternate approach which is similar enough, it will still get flagged at some level. Okay, so in some cases the detection will be on the network, that okay, if something like this is passing through a network, this is probably this particular malware. There will be another detection on a file signature, another one on memory signature, and yet another one on behavior.
Yeah.
And then rest is thoughts and prayers. We hope to catch it at some layer.
Yeah. It is there. But since you're like in so many years of detection, uh, how many like 0 days have you seen any 0 days, or it's like very few or rare?
Okay, so in case, yes, we have dealt with 0 days. Even I have done so in my various jobs. And
Mm-hmm.
for 0 days, especially if it is actually a 0 day, we don't really get a sample.
Yeah.
Okay, we have the
Yes.
information, we don't really get the sample. What we get is some description of its capability
Mm.
and how it is used. Okay, so let us assume that there is some particular service for which there is some 0 day, and
Mm.
someone from threat intelligence comes in that hey, we have information about some 0 day which is exploiting this particular service, and it
Yes.
seems that in this particular service this particular component is somehow getting exploited,
Mm.
and it results in either arbitrary read write of data or arbitrary code execution or some sort of limited code execution or OS command execution, right? Something like that, or some limited read write, whatever. So even though we don't have the 0 day, we still have some idea about how it is used and what happens when it is successful. Okay.
Okay.
Then we take a look at the service that is affected. Okay.
Mm.
And we go through its documentation quickly to see if this particular component is exploited. That means that there must be some network service which is going to interact with this particular component in some way.
Mm.
We figure out all those requests, right? And those are the only possible ways this can be triggered, because it relies on some specific component. Okay, so we isolated those particular network requests, and then we try to figure out the behavior of that module. That
Mm.
okay, if there is a case that it is going to provide arbitrary read write, in how many cases this does the arbitrary read write part, right? And if it does so, in are there any restrictions on the paths? Like there are
Mhm.
only a specific set of paths that it can read from or write into, or it is just complete wild west, something like that. So we figure out that part as well, right? And
Mhm.
then what we do, we put little bit of correlation. Step one, we take a look at the network. Okay. Uh, there will be cases where we have deep packet inspection capabilities, either directly in our own product or we provide integration with some third party product. Okay.
Mhm.
So we will put a detection on that okay, if there is this type of network request coming, going to
Mhm.
this type of service and it contains something like this, which using which we are able to basically identify those set of network requests which can trigger that particular module, that will be one detection, right? Then
Okay.
request comes to the service. Is that service writing logs? If yes, are we ingesting those logs? Right? If not, what we will do, we will try to see if we can identify when it is performing reads and writes and what are the usual paths when
Mhm.
it does so. And then what we do, we put a very simple rule saying that, okay, trigger an alert if this service got a network request uh, from some suspicious IP, right? And it does some sort of file read write outside the limited number of paths. Raise an alert. That is a very crude detection. Okay, not extremely reliable. It is going to be false positive prone, but again, a blind uncle is better than no uncle.
Yeah.
Okay, a very generic FP prone detection is still better than absolutely no detection at all. And that is the first thing that gets pushed. That hey, we are seeing reports of this type of 0 day. We have pushed a detection. Okay, try
Oh.
to investigate if you get a hit on that particular detection. And once that
Okay.
part is done, then we start focusing on fine tuning it. Is there something else that we can rely upon? Or can we do some emergency update on all the agents and cloud side of things to collect some extra data, etc., etc. So yes, this is something that we have done. There was some 0 day for I think some Atlassian product for which we did. We didn't really have any sample for it when we actually pushed the detection in one of my previous jobs. Same goes for Log4j. When
Mhm.
we got reports of Log4j, and in some hours, I think yes, it was in some hours we were able to push uh, a very crude detection, right? And even before we got any actual sample for Log4j, uh, our teams basically managed to prepare a small code which we packaged as an independent utility, right? Saying that, hey, you can run this in your infrastructure and it will scan your infrastructure and flag wherever you have linked that Log4j thing. So
Mhm.
even if you don't know whether you are compromised or not, you will still know that whether you are exposed to it or not,
Mhm.
right? Even that is valuable information in face of a 0 day, which is going to be exploited at mass scale. So we did that, and then we kept refining the detection. In some cases, we also identified cases where customers didn't know that they are breached.
Mhm.
And we were like, hey, we are seeing this type of activity, and this is not normal. You need to
Mhm.
investigate. Turns
Yeah.
out that they got delayed in something. But okay, this is something that we have done multiple times. And most of the time, this is how things happen. You basically figure out in how many ways this can happen, what is the observable behavior. You
Mhm.
publish a detection on that observable behavior, right? And then you basically fine tune it to prevent massive FPs.
Is it easy to create 0 days now with automation and everything? Do you think
No,
it's on the rise of
no,
increase now?
no,
Not
no.
at all. Little 1%.
No, no, no. Writing, finding 0 days, writing 0 days is still massive pain in us. You need to do a lot of fuzzing, and then for fuzzing outcome, you need to do a lot of analysis to figure out if that is exploitable or not, and if it is exploitable, what you will get after that, right? For example, if you find something which looks exploitable, but that results in a very limited exposure from the memory, that is not really useful. But
Yeah.
if it provides arbitrary read write from the memory, it is more useful. It provides arbitrary read write for entire file system, it is immensely more useful.
Yes.
And if you end up finding something that provides arbitrary code execution, you have hit the jackpot.
Hmm.
So again, this is not very simple task,
Hmm.
and that is why you don't really see 0 days appear randomly. It will always be in some deep corner of internet where this comes, and then it gets weaponized immediately.
Yeah. It comes, it
Right.
spreads, and it vanishes.
Yes, yes, yes. Because there is a very small window in which you have to recover your uh, return. The ROI window is very small, right? The effort is huge. So within that short span, you have to sell it to bunch of parties and for a very fat price, because again, you have spent your entire team has spent a long time chasing this
Hmm.
stupid thing, and the party who is purchasing this from you has to recoup their cost of
Yeah.
procurement of the 0 day. Right? So obviously they will try to just blast it out, compromise as many as victims, and figure out some way to make money either by stealing and selling the data, dropping ransomware, whatever.
What do you think is one overlooked and underlooked aspect in cybersecurity?
Overlooked is like everyone wants to be hacker by running bunch of rules. Everyone wants to do that, right? And for underlooked, the most okay, the first position will go to programming, because
Hmm.
every DB and bhaiya on YouTube is peddling the same lie that you don't need to be a coder to be a hacker. Bro,
Yeah.
programming is basically literacy of computers. Okay, you want to get into security in any capacity, barring risk and compliance, because that is more on legal side. You need to understand
Right.
legal aspects more. But other than that, you are going to require programming. Otherwise, your career is basically going to be stunted. And that is a reason why so many people have a rather stunted career in security. They want to get into that. They got into this, but for some reason, they never learned programming. And there are many people who got into security because they hated programming.
Yeah.
I go to conferences, I go to meetups, I meet people, and there are a lot of people who have said this to my face that, sir, we got into security because we did not want to write code. And now you are telling me that
Yes.
we have to write code? Math is not mathing, bro. We didn't come here in this field to write code.
Yeah.
So that is a problem.
College students. That's a very big myth among college students till date.
That myth is being sold to them on YouTube by various bhaiyas and didis. Sapne suhane ladakpan ke.
Okay, sir. One final question. If tomorrow you had to start something completely new outside of your current work, what area of like research would you dive into next?
Area of research? Does it have to be research?
Anything you want, not necessarily research. What would you prefer?
Ah, okay. If I want to get out of this thing, I will probably learn how to repair engines and gearboxes and probably start a workshop. Okay, that okay, you got a toast engine, your service center is asking you fat money, give it to me. I am willing to burn my days and nights in trying to recover that. And in fact, if you take a look at that side of things, and if you are someone who uh, is able to restore rather old cars, right, in pristine
Hmm.
conditions, especially their mechanicals, not the body,
Hmm.
you can make a lot of money.
Is it?
Yes, yes. Yeah, you can make a lot of money. The market is small. I think the number of people who will procure your services are small, but they have deep pockets and they are really passionate about their old cars, right?
Hmm.
And they are not uh, shy of paying fat
Yeah.
money to someone who. is actually able to restore their car in very much functioning order, which means that you will also have to prepare bespoke parts. You will end up with cases where there is some part which is out of production since
Mm.
many decades. So you have to know how to take accurate measurements, how to do all the drawing stuff, how to either make it yourself or get it manufactured by someone else who knows how to do this metal part, right? And then you get that stuff, you fix it, repair it, get it working, and then you also need to figure out how you are going to sustain this, because uh, various other parts will also need similar type of treatment, right? So that means you also need a small inventory, or at least inventory of slot time, that hey, this is the lead time. If you give us an order for this particular product, in these in duration of these number of days, we will be able to fabricate it or manufacture it for your car for this particular reason. And that has a lot of money in that market. I have been interested in these things.
Nice.
So I will probably start doing that. It is just that my parents will be beyond pissed, but
Typical Indians mentality.
they'll be like, अरे इतना सब करके मैकेनिक बन गया.
It was a very nice time, sir, talking with you, having this discussion. Thank you so much
You?
for joining me today on such a short notice, and having this conversation, breaking down Linux malware EDR evasion, and giving practical advice for students. For everyone listening, I hope you got as much value out of this episode as I did. Don't forget to like, share, and subscribe. Thank you for listening, and see you soon in the next podcast.